Hello everyone. In this next video, we're going to take a look at the three-way mixing valve and the four-way mixing valve. You would use these valves if you're going to put in or install in-floor heat. These white pipes right here above the floor and the ones up here in the ceiling to heat the floor above. Okay? So far we went over oil fire boiler with a baseboard rad. We went over an electric boiler with a cast iron rad and an indirect hot water heater. So in this video, we're going to take a look at mixing valves for in-floor heat. The reason why we have a mixing valve right here, this is called a three-way mixing valve, is because the temperature you want going through these white pipes in the floor is quite a bit lower than what you would use to heat up a cast iron rad or a baseboard element. The maximum temperature that goes into these pipes here is roughly about 140 degrees and can be all the way down to 90 degrees. The temperature difference just depends on the application. Where if you have it in a house, you would probably want these pipes to be hotter, say probably around 130 or so, where if you had this in a garage or, for example, the school down here, this mixing valve would probably be set for around 90 degrees, okay? And the reason for that is because if it's in a shop or school, out in the shop, you're working and it'll just make you that much more hotter if the floor is 130 degrees instead of being set at 80 or 90. You notice these pipes right here, they just stop. There's just basically one little loop. If this was in a house, those pipes would go all over the floor, all over the mock-up, folks. Everywhere that we walk, there would be these pipes. And you can see how they're installed. It's just with the Astro clips or J clips that we were using to run the hot and cold water lines. Now, when we convert it up in the ceiling, it's the same thing. You can see the J clips or the Astro clips are hung off of the floor joist, every floor joist, right? We talked about this in class, Preston, about the hangers for PEX pipe. It says in the book you can go every 32 inches, which pretty much is every floor joist, second floor joist. But when you put hot water through it, if we didn't have those clips on every joist, the pipe would sag down like spaghetti, right? And you wouldn't want that. You want to keep the pipe up inside the floor joist. You can also notice the floor joist, there's a space. This pipe here isn't exactly right below that plywood. And the reason for that is, if I took that pipe and put it right against the plywood, kind of like we did down here on the floor, up top, if I was going to install in a hardwood flooring, it comes with a spike that's about 2 or 3 inches. So if I drove that spike and went down through the wood, I didn't want to come down through and hitting that piece of pipe. It will cause a leak. Okay? Now down here, where we have it on top of the wood floor, what they would do in this situation is they would over pour this with a permacrete. It's same like a concrete, it just doesn't weigh as much. And the concrete would come up over above the top of these pipes, right? And then you would have a concrete floor. Either way works. This way here, the overpour, in my opinion, is more effective because it's just right below the floor. Right here is you have to heat up the area. You would have to insulate this so it would heat the floor above you. And again, we'll get more of that when you guys get down here and we'll start going through the modules. So we go back over to this three-way mixing valve. You guys can notice there's a H, a C, and a mix, okay? So H is your supply, C is your return, and the mixed is the water that we're gonna put down in through the pump, down through the zone valves, and in through the in-floor heat. Okay? It's extremely important that you hook it up the way it shows you right here. You can't put H over here and vice versa, because what happens is you'll have the return going into the supply and the supply going into the return. Your H is basically your supply line. So that would be the hot water coming off the top of the boiler into here. This valve also, the top of it, you can turn the handle one way or the other, left and right, and you can increase or decrease the temperature that you're putting into the in-floor system right here, okay? So you turn it one way or the other way, depending on what temperature you want, okay? So right here will be the supply line. So this here will be coming from my electric boiler, my oil fire boiler, my propane, something that's gonna heat up my water. So it'll be coming in through here, let's say at 180 degrees. It's gonna hit this mixing valve. It's gonna come down through here. It's gonna turn, go through this ball valve. The reason we have this ball valve on here is because this pump is gonna break. So we wanna be able to isolate the pump with this valve so we can fix it, okay? It's gonna come down through here, through the pump. It's gonna go down, in through the heating system, right? All the way through this pipe. It's kind of cool when we're down here and we get to start this up. All these pipes here, you'll see bubbles. There'll be bubbles flying through here until we get all the air out of the system. It comes back here, it goes over. And you can see we have a couple of these PVC 90s on here before we going through the floor. They serve for a couple reasons. One is to make a nice 90-degree bend so I don't kink the pipe. And the second one is for concrete. They're gonna be pouring concrete up along this floor. You don't want the concrete to be right against the pipe, because when they go to finish this, they're gonna have a machine go over this. Kind of looks like a big fan on the end of a handle, kind of like a lawnmower. And these fans just turn and turn and turn and smooth the concrete so there's not a whole bunch of bumps in it. When they're doing it, they don't take care of anything. So they would just take that machine right up against here. Those fans would go and hit this pipe. If this plastic cover wasn't on here, they'd probably cut that pipe in half. So that's why you always want to put these on when you're turning up out of concrete. So then we'll come on back up here. You'll see we back up here. We have a boiler drain. Again, that's to help in case we need to get the air out of the system. And then we have a ball valve, right? And we have a ball valve here that we had on the supply so we can isolate this loop. The water comes back up through, in through here. Now this is where it gets kind of cool. Right through here, this is my return. So this pipe here would go back to the boiler to get reheated, right? To go through and then come back through the supply. But what happens right here with this mixing valve will take some of this water through here and it'll mix it with the hot water coming in. So the cold water coming in here is mixing with the hot water to the temperature that's set on top of this valve that goes down and in through the pump. So when the water's coming back through the return, this mixing valve says, okay, I want so much water is gonna come this way. I'm gonna use it to mix. The other water that I don't need, I'm gonna send back to the boiler. It's gonna go up here through the return, all the way back to the boiler, get reheated, and then come back down in through the supply again. Right, and then this is gonna go through the pump. So what I have over here is, we were talking about zone valves before, and I was showing you this part, right? This is the control part that goes on top of that part, right? And once we get down here, I'll show you how they go together. This just basically clips onto here, and these wires will go to your thermostat. So let's say I'm cold, I go home, I turn my thermostat up, it sends power down into this valve. This valve opens up, the zone valve, and then it says, okay, Mr. Pump, over here, I need you to pump water, and what you gotta do is pump water up and through to the zone that's upstairs. And the water's gonna go through all through those loops, all the way down through here. It's gonna turn and come back. And again, you take a look at the mock-up, all this ceiling. If this was my house, I would have in-floor heating pipes all through here, okay? And then the water will come back down, comes back down the return, goes through this valve, comes back down here, goes this way, and then again, goes over to where the mixing valve is. And the mixing valve says, okay, I'm gonna take a little bit of water through here and go down here and mix it with whatever this is set for. Whatever water I don't need goes back to the boiler. And again, it's a closed loop and keeps going over and over and over again. So I just wanted to show you what the head of that control looked like. When you buy a zone valve, it comes in two pieces. It comes with that head and it comes with that body, okay? So the body and the head just clips on and off here. And we'll show you that again once we get you down into the shop. Now this would be two zones in this system. There's a zone here for upstairs, and I would have another zone down here for downstairs. So if this was my house, I would have two thermostats. I could have 10 of these. I would just keep on going through here, put a zone valve, zone valve, zone valve, zone valve, zone valve, zone valve, all the way across, and every thermostat would connect onto this. The only thing that happens with this, if I had 10 zone valves, this circulator pump will be running a lot more than if I only had two. And it's designed to do that. You can see in the top of this pump, I hope you can see it right there. There's high, low, and medium, or sorry, low, medium, and high. So you can set this to whatever speed you want. I always just leave it at high. I don't know why, that's just the thing that I do. Every one I have at home, I have it set at high, but if you're only at a small house or a couple loops or a garage, you might only need it at low. And basically, what the high, low, and the medium is just how fast the propeller in this pump will spin. Okay? And on to another note, we were talking about hangers and supports in the last course, and we're talking about split ring hangers, which are right here. We had those, and we're talking about sealant flanges. You'll have those. And then we have a piece of threaded rod in between the two, okay? I could cut that threaded rod whatever length I want. I could have it out here, or I could have it in smaller, whatever you want. So when we did this one, you can see all the threaded rod are cut the same because I want the project to be nice and level on the wall, okay? You can also know in this split ring hanger right here, right there, there's a piece of red rubber. And again, that's because I don't want the copper to touch this here part of the steel. Because if I do, the copper's gonna lose, the steel is gonna eat a hole through the copper, and I'm gonna get a leak. So what we do is put a little piece of red rubber in there, and we'll be going over that once you get down to the school. We have a whole great big sheet of it, and we just cut off what we need. And we put in each one of the hangers in there. Now, if this was black iron steel pipe, I wouldn't need that because the hanger and the pipe are still made out of the same kind of steel. So one is not gonna rust out the other one. So that's your three-way mixing valve. You guys will be doing this project once we come back down to school. And again, all this stuff here will be on a piece of paper. You will get a drawing that looks like this, right there. Picture of your three-way mixing valve, the pumps, all the valves, the zone valves, the drains, everything that needs to be put on there. But you can also notice there's no measurements, right? So you got to design this project. I don't care how long you make them. I just want to make sure you have everything in sequence on this piece of paper matches the project that you're going to do. Okay, so this one here, when we did this one, we went over to the right, but next time if I wanted to, I could take this and go over to the left. It just means I got to switch the hot and cold, switch this valve the other way to pipe it up. Okay, so that's your three-way mixing valve. What we're going to go over to next is the four-way mixing valve, okay? Again, you would use this valve for in-floor heat, okay? You can see the in-floor heat in this one. We put the loop up in the ceiling, okay? This valve is designed in case you have in-floor heat plus baseboard radiation, okay? This valve lets you do both types of heating with one mixing valve, okay? You can also notice when we hook this one up, guys, a lot of it is done in black iron. And again, the reason for that is price. If I try to do all this with copper, which I could, it would cost me probably 4 times more than what it would if I did it with this black iron fittings, okay? So that's why we did all this with black iron. And then afterwards, as we get up past the pumps and the zone valves, we convert it over to copper. And again, once you get down here and we do the projects, we'll show you when to convert over and when you don't. Now on this valve, you can also see there's a handle in the center of it, right? And there's numbers. You just turn the handle to what number you want for the temperature that you want to put in through the mixing valve, in through your in-floor heat. Now when you buy one of these valves, all these temperatures and paper, all the literature will come with the valve in the directions. So it'll tell you, okay, number 7, I think that is. Number 9, we'll say, okay, number 9 will give you 140 degrees or something like that. And then number 5 might give you 110. It'll tell you what each number is and what the temperature is for. The same thing goes with this one. This line coming in here, going in this way, is the supply line, okay? So this is the hottest water coming from the biggest pipe off the top of the boiler. It's coming in this way. Before we hit the mixing valve, we have a T. As we follow this T up, we have an isolation valve because we have a mixing valve that's gonna break, so we wanna be able to fix it. And then as we come up here, we have a zone valve. Then we have another valve to isolate the zone valve. And then if you follow this pipe, it runs over and down and in to the baseboard rad, okay? Remember, like I said before, baseboard radiation takes a lot more heat and hot water to heat up the room than it does with in-floor heat. So when we go back to this project on the wall, as you can see, the first tee coming off before I hit the mixing valve will be the direct hot water from the boiler. So this here could be up to 200 degrees. So this water's coming through here, this pump is kicking in, it's going up through the zone valve, all the way down through the copper line, in through the baseboard. And as we follow the baseboard, if we put water out, we got to get water coming back, which comes up the return right here. Okay, as the water comes through the return, it goes into the mixing valve. And again, mixing valve pretty much does what it says. It mixes water. So it's going to mix with the hot water coming here, back with the return water. Okay, whatever it needs to mix, it's going to use, and then the return water is going to come down here, back to the boiler. So that is the heating system for the baseboard rad. Now what we're going to do is we're going to follow this pipe in. We've already done that pump. That's for the baseboard rad. We're going to come into here, into the mixing valve. The mixing valve is what we're going to use to heat the loop that has the in-floor heat, okay? Because remember, for in-floor heat, we don't want any more than 140 degrees because we're heating up the whole floor. So we usually use it around, in a house, around 120 or so. So I would turn this to whatever desired temperature I would want. I would turn my thermostat on. My thermostat would start this zone valve. This zone valve is going to say, okay, circ pump, time for you to kick in. The circ pump's going to kick in and draw water off of the mixing valve, which is the supply line here, right? So this pump's going to start pulling. It's going to pull water in through here, turn, go up through the mixing valve, up and through the circ pump, up and through the zone valve, and then up and through all the in-floor heat loop that you're going to have in your house. It's going to come back. It's going to come back down the return, right down here. As we come down here, you'll see a boiler drain again. At the every return of every loop, you want a boiler drain because in case we have to purge it or work on the system, we want to be able to drain the water down. It's going to come down through here, through this boiler drain, or through this ball valve. It's going to hit here and it's going to go this way. And again, this is where the mixing valve is going to say, okay, I'm going to pull so much cold water in with so much hot water. I'm going to mix it. Whatever I needs mixed is going to go this way to the in-floor. Whatever I don't mix is going to go down and back to the return to the boiler to get heated up again. And again, it's an enclosed loop and it's going to keep on circulating the same water around and around. Again, guys, that's a whole lot to take in without actually coming down here, seeing it, putting it together. But again, this is what your project's going to look like when you come to do it. You can also see we use the split ring hangers again, but these ones here against steel, so there's no red rubber in here. Okay? And we are also going to get a piece of paper. You'll get your drawing, just like we did for all the other projects. But again, same as the other ones, it'll tell you the sequence I want everything, what they are, right? But it doesn't give measurements. Right along here, there's no measurements of how long these pipes should be, these pipes should be, these pipes here. That's up to you. That's when you go over to your work area and you start designing your own. Okay, so this is the 4-way one. Again, this is the 3-way one. We have both of these down here. You will be hooking them both up. This one here kind of sometimes takes more time just because you got to thread all this together because it's black iron with pipe wrenches, dope, and so on. And we will be hooking both of these up right there. 3-way, 4-way. Hope you enjoyed this video, folks, and we will talk to you soon. Bye-bye.